Hey everyone, I'm Kevin Patches, a field engineer here at One Energy. Welcome to today's Science Short, all about batteries. We're positive that you will enjoy this one, so get ready and charge up. Batteries have been around for a long time. The first modern battery was created in the 1800s, but similar technology has been around for thousands of years.
It's a long time, right?
Nowadays, batteries play an important role in our everyday lives. We typically think of using batteries to power small things, like remote control cars, or a TV remote, or a flashlight. But batteries can also be used to power big things too. And when we say big, we mean big. Think cars, trains, and planes. But how do batteries work? Let's start with the general setup. Batteries have a positive end and a negative end. The positive end is known as the cathode, and the negative end is known as the anode. The anode and the cathode are usually made of metal. In between the anode and the cathode is something called an electrolytic medium, which is another word for a substance through which charged atoms easily flow. For example, a typical AAA battery contains a solution of potassium hydroxide as its electrolytic medium. A charged atom is an atom with an imbalanced number of protons and electrons. Charged atoms are also known as ions. For a refresher on charge, take a look at our previous Science Short on atoms. Now that we have a general idea about how a battery is set up, let's dive deeper into how a battery actually operates. Batteries function by way of chemical processes, and as with all things related to chemistry, reactions are key to the function of a battery. Chemical reactions are interactions where one or more atoms come together to form a new combination of atoms, also known as molecules. The two reactions that are important for our battery discussion are called reduction reactions and oxidation reactions. Reduction reactions are a specific type of reaction where an atom gains electrons, whereas oxidation reactions are a type of reaction where an atom loses electrons. I like to remember the difference using the acronym OIL-RIG. Oxidation is loss of electrons, and reduction is gain of electrons. Now that we've got a little bit better understanding of chemical reactions, let's get into how a battery is able to power so many different things. Reduction and oxidation reactions occur at different locations within a battery. Reduction reactions occur at the cathode, remember the positive end, while oxidation reactions occur at the anode, the negative end. This means that the atoms at the anode lose electrons, while the atoms at the cathode gain electrons. If we take a look at this basic battery setup, the electrons flow from the negative end of the battery to the positive end of the battery. This means that the electrons lost at the anode travel through the circuit to the positive end, or the cathode of the battery. That's the main premise of how a battery produces power. Electrons travel from the oxidized anode through a circuit to the reduced cathode. Electrons can then flow through anything that is connected into the circuit as they pass by. Therefore, if an item is within the circuit, it can be powered by a battery. But where does the electrolytic medium in the battery come into play? This medium allows atoms that have lost their electrons in the anode to travel to the cathode. Here, they recombine with the electrons flowing through the circuit. Over time, these electron-hungry atoms run out, so the battery cannot provide any more charge. Some batteries can then be recharged, like the batteries in cell phones, but for many batteries, it's time to be recycled. One type of common battery is a lithium battery, examples of which include some variety of a AAA battery and a AA battery. In most lithium batteries, lithium metal is used as the anode, remember the negative end, while a metal oxide is used as the cathode, the positive end. This means that the lithium loses electrons while the metal oxide gains electrons. Here's an experiment to demonstrate. Let's take a look at current flow from the lithium anode to the metal oxide cathode in real time with this small light bulb. If I put one end of the light bulb on the negative side of the battery and one end of the positive side of the battery, we can see the light bulb glow. As the electrons move through the circuit, they transfer their energy to the light bulb, allowing it to glow.
Isn't that cool?
Different size batteries can be used depending on the energy requirements of the object the battery is powering. For example, some items require AA batteries because they tend to last longer than AAA batteries. AA batteries are physically larger than AAA batteries and can hold more charge. But remember, batteries can be small or they can be big. To apply this concept on a much larger scale, let's focus on how batteries impact what we work with here at One Energy. We communicate with our turbines using the internet, connecting to each turbine using internet routers. Should we ever lose power to these routers, we have a backup battery system in place so that we can still communicate with our turbines. We use batteries to make sure we always know what's happening at each of our turbine sites. Thanks for watching. We hope this video has you energized about batteries. Be sure to subscribe to our YouTube channel, and remember, challenge everything.